looking at sort of some of the stuff in the beginner skill map, which you guys probably saw. Some of this is a little too easy, even if you've never programmed before, because of course you have to remember that mate code and Scratch and a few of these other things, right? They're designed for beginner programmers, which mostly usually means children who have very short attention spans and whatnot, and so hence why the tutorials are very, very, like, they're broken up into the smallest possible subunits. Okay, so what we're going to do today is go through a let's see, where is it? Sorry, they've moved things on me. Here it is. Okay, sorry. Space Adventure. Okay, so find this one, and let me go back to the main menu. So it's in the Skill Maps one, and it's called Create a Space Adventure. So we're going to go through probably most of this today, and then you guys will finish it and then add something to it. So essentially what we're going to end up making is this sort of space shooter thing, where you can see sort of over on the right. If any of you guys played Galaga, or really any of those kind of shooting flight games where you can there's enemies, and you can shoot them, and okay, the some of them get really fancy where you can pick up like different types of weapons. It'll make you shoot multiple missiles, or multiple missiles at some funky angles, or something cool. But just to get the basic stuff down, we'll kind of start here. So this is kind of what it'll look like, roughly speaking, when we've added all the things that are sort of in the tutorial part of it. But obviously, there's a lot more that we could add. Okay. So what we've got basically going on here, right, is that you have a sprite that you have full movement control over. Okay, in this case, it's the little spaceship. And there's enemy spaceships of some sort. Okay, and then the other thing is, you see underneath the spaceship, there's that like yellow bar. What that's meant to be is like a fuel gauge kind of thing, so that you could run out of fuel if you don't periodically grab one of those. Um, and then we'll also add some logic for what happens if you run into an enemy, or something like that. Then maybe you should lose a life, or lose a health point, or something like that. And then we've got this background, which is sort of scrolling very slowly, to make it sort of trick our eye into thinking that we're actually moving, flying through space. Okay, so anyway, all right, so let's start. And since I've already done these, we have to restart and go through and see kind of the stuff we need to do. Okay, so the first thing we need to do is set the background. Okay, and like I think we talked about on Tuesday, or Thursday rather. Okay, there's all of the different code pieces are organized into this color-coded scheme, and most things are going to be where you would expect them to be. Okay, and so scene would be for the background, and we want to set the background image to what, and then we'll pick under my assets, and we'll pick this spacey kind of background that they've got here. Okay, great. All right, so that was easy. And then we want to make this thing scroll. Okay, and so let's drop it in there and then take a peek at how it's going to work. All right, so what obviously do we need to change here? Yeah, it's going up and to the left. Okay, so which direction do we want this thing to scroll? Just down. Okay, so I want to make the VX component of this 0. Okay, and then the other thing is, it's scrolling up right now. Which way did we want it to scroll? Down. Okay, so what do I need to change here on the VY? Yeah, positive something. And I'm actually going to also change it to something maybe a little bit slower. Um, the exact number that you pick there is sort of does that look roughly good? Right? And obviously, one thing that is true, any of these numbers that are in sort of a roundy socket can get replaced with a variable. So it doesn't have to be the case that the speed that it's scrolling is constant the entire time that the game is running. And that makes sense. Maybe like in one level, you make it look like you're going faster, and or do something like in Star Wars when they've got to go get the torpedo into the very conveniently placed ventilation tube or whatever it was, and they're the original three Star Wars movies. Where they're flying around the Death Star and they're in the little like canals or whatever that are on the surface of it, right? So maybe there, if you were to do something like that, then the background would scroll faster. Okay. Anyway, so it can be variable. And in this case, we're making our shooter so that it looks like we're moving vertically, but we could also make one where you're flying horizontally, like Flappy Bird or something. Obviously, that's up to you. Okay. So background, 20, 10, whatever. That's sort of a design decision. Okay. So now we need to make a sprite, and the sprite is going to be set my sprite to be a sprite of kind player. Okay, so there's a couple things going on here. The first is my sprite is the name of the variable or the name of the object. It can be whatever we want. My sprite is just a default, and since we're only going to have one player character, there's no harm in just using that name. Um, and then it needs to be so it's a sprite of kind something that has some sort of art attached to it. Now, right now, it has no art attached to it. So if I ran this, it would not, it would be in existence, but we wouldn't actually see it anywhere on the screen. Okay. So I just need to change the art. And in this case, they've already made some stuff for us. So we'll just pick this little rocket ship here. Okay, great. Okay. And that gives me art with uh, the thing. And you'll notice, where did the sprite appear on the screen? Yeah, at dead middle, it just defaulted basically to there. But we can't move it, obviously, because we haven't added any controls for doing so. Okay, so that's it. It just sits there. Okay. So a couple things to kind of keep in mind, that if we're creating multiple sprites, they need to have probably different names. Um, and I say probably because there's other ways that you can, uh, tell one apart from the other, which we'll talk about later. And then the other thing to keep in mind is what type this is. Now, the type, or Make Code calls it a kind. These are the ones that are sort of default there. But of course, you can have as many different kinds and call them basically whatever you want. Um, and uh, the sort of obvious ones that you might want would be enemies, players, projectiles, etc. Okay. Now, in the enemies thing, in this sort of simple demo game, we'll only have sort of one type of enemy, but you could have sort of multiple types of enemies, or like bosses or tough enemies or mini bosses or things like that have different properties. But the kind is important because that will be one of the ways that we handle what to do if, like, we shoot something or we run into one of the other sprites. So if we run into an enemy, then what we're going to detect is an object of one kind overlapping with an object of a different kind. And when we do so, the kinds is how we tell what's what. Okay, so those will be important. Um, the defaults to player, which just so happens to be the one at the top of the list. And for our player, obviously, that's what we want. Okay, So the sprite is now in existence and it has some art attached to it, but it obviously isn't moving around. Okay, so to do that, we'll just use the move my sprite with buttons. And if we hit the plus there, then it gives us the option to specify what the horizontal and vertical velocities are that our sprite is able to move. And if you hit the up or down buttons or left or right, it it's smart enough to know what to do to the 100. It'll negate it if appropriate. Okay. So now that I have that, I can move my sprite around in any direction by combining the arrow buttons. And then obviously that 100, we could tweak those hundreds to be faster or slower. That's kind of up to you. Um, okay, so does that sound good? Yeah. But oh yeah, go ahead. Yeah, exactly. So if you hit left, it would move right and vice versa, which would be a really good way to drive a player crazy. But yes, technically you could do it, right? So, um, yeah, and that would be um, well, okay, actually, there would be one potential instance where that actually would be exactly what you'd want to do. For example, let's suppose that you were programming a flight simulator, right? Uh, how do you make an airplane go up? You pull back on the yoke or the joystick, right? And you go down by moving it forward. So there you'd use a negative in the Y direction to flip them, um, but the left and the right would be the same. Yeah. So, uh, but if you flipped both of them, that would probably give me a headache pretty quickly. It's kind of like, have any of you guys ever seen? Uh, so you all know how to ride a bicycle, right? When you were kids, you learned how to ride a bike. You probably skinned up your knee a few times, right? That's just sort of a rite of passage. Um, but when you turn the handlebars one way, you go left. So many years ago, I came across it was either on YouTube or some documentary or something about like the brain, and this guy built a bicycle that had a set of gears so that when you move the handlebars left, it actually moved the wheel right and vice versa. And it was sort of, he was talking about how like his brain had to unlearn how to ride a bike and then relearn how to ride this bizarro bike. And so, of course, at first he's like, wobbling all over and falling and crashing and stuff. But eventually he gets it and starts riding it like it's normal, and everybody's kind of looking at he's riding by and like, what? Wait, what? Um, yeah, I'll have to Google for that and see if I can find it because it was pretty hilarious, um, but also interesting from sort of like a neuropsych kind of perspective. Okay, anyway, yeah, so those can be negated if they need to be. Um, and also the number can be changed, right? 100 is just the default. Does that look like it's pretty reasonable given the size of the screen? Yeah, I mean that's again a design decision, but looks pretty good. Um, One thing that we'll want to fix, although we don't have to worry about this right this instant, is what happens if I hold the left button? Yeah, it goes off the screen and I have to, wait for it to eventually come back. Okay, so we could add some logic to handle that so that we don't go off the screen. Let's not worry about it right this instant. Um, okay, um, but yeah, what happens if you do that? Uh, and then, there's a, uh, there's a thing for it, which is there's a toggle here for making it stay in the screen. Okay, so all that does, oops, right, is it prevents us from going off the screen at all. Now, the way it works is, um, so the screen is 160 by 120 pixels, okay? And so the coordinates of our spaceship have to be x coordinates between 0 and 159 and y coordinates between 0 and 119. And if they exceed that, we just tell the buttons to stop working. Okay. Now, in MakeCode, they have this one magic block that sort of does it for you. But we could sort of manually code this if we wanted. The other thing to note is you see how this is sort of a toggle. Objects that sort of have this pointy socket are variables that can only ever be true or false, which means actually we could replace that toggle with a variable. So we could have it be the case that at some points in the game you could go off the screen, and then other points you can't, right? Now, whether or not you actually want to do that, again, is a design decision. Maybe you do, maybe you don't. But you at least have the ability to, should you want to. Okay. All right, so that was easy. And that's it for the first one. Okay. Any questions on this first guy? This is probably pretty straightforward, I would hope. Oui? No. Oui? Play bien? Okay. All right, so let's move on to the next one. Okay. So we start with basically everything the way it was before. Okay. Um, and now what we want to do is start to make it so that we have enemies and we can shoot at things. Okay. So the event that's going to trigger being able to shoot is this event here, on a button pressed. Okay. You've got the following buttons that you're able um, to toggle. Okay, so you've got the four directions, you've got the A and the B button, you have the menu button, which is on the simulator. You can hit the menu, and if you hit that, then you can change what happens here. So if you have the menu button, then you can change the volume, get statistics, show the console, which can be useful for debugging, uh, and then of course close it and go back to the game. Um, okay, but in our case, we want the A button to be triggered to the fire button. Um, and so you'll notice how the A button, like I can't take this thing and put it inside there. It is a sort of start block that things go inside it. It can't go inside anything else. Okay, does that make sense? Okay, so what do we want to have happen when we hit the A button? So we're going to make a projectile, okay, and those are under the sprites tab. And so we're going to do this guy, okay, so set projectile to projectile blah from my sprite with Vx and Vy. Okay, so what do we have to specify here? We have to specify how fast the projectile moves, what its art is, and where it starts from. And where it starts from is going to be, in our case, the player sprite. That makes sense. Okay. How fast does it go? Well, we can tweak that. And what do we want it to look like? Well, again, we can also tweak that. Okay, so let's pick under the art. They have one here that's, I think, this one. It's called Dart. I think that's the right one. Okay. Um, and we want it to start from our sprite. Okay, obviously this could be replaced with a different variable. So like if we wanted our enemies to shoot back at us, we would change this to whatever the variable name to go with the enemies was. Um, and then our velocities here are going to be something. Okay, now we probably don't want to have there being a horizontal component because we're doing a vertical oriented space game. And our VY is 50. Well, let's try it out and see how it looks. Um, oops, oops. Okay, so what's the problem? Yeah, it's backwards. Okay, and before I negate it, does the speed look good or we might want to maybe turn it up a little bit. What do you guys think? Yeah, let's try that and see how it looks. Good, roughly. Yeah, and obviously we can tweak it. The exact number is not so important right now. And like I mentioned before, of course, these could be variables, right? So in most of these space shooter or, Air Force style games, you have you can pick up different types of weapons that some shoot faster than others, or others have like two beams, or shoot like a fan of things or whatever, right? So you certainly got all of those possibilities. Um, okay, so for example, let me just demonstrate that we could do something like that. Let's do something like this. See how they're kind of spreading a little bit? All right, so let me maybe adjust the horizontal speeds. Yeah, to make it kind of have like a fan. Okay. Whatever, right? And it's just for sake of fun here. Okay, great. So we fixed the velocities, and it's yelling at me because I didn't make it what it said to make it. But okay, so this screen here, let's just remind ourselves about what the coordinate system was. So where is the origin in our coordinate system on the screen? Yeah, top left. Did you have a question, Key, or no? Okay. So yeah, so the origin is up here at the top left, okay? And the positive x-axis runs horizontally. Okay, that makes sense. That's like it is in math class. But the positive y-axis runs down rather than up. Okay, so when you're thinking about your positions and your velocities, you just need to remember that the coordinate system is not exactly like it is in math. Okay. Um, and it's like that for historical reasons. Okay, if we think back to what computing looks like in the 50s and 60s and 70s kind of thing, it makes sense why this was the decision made at that time. But, we have to live with the consequences, basically. Uh, yeah. So, I mean, it's kind of like, has anybody ever done like circuit wiring with breadboards and, simple digital circuits and things like that? Or done really anything with DC electricity? Yeah. Okay. So the positive, right? Which way does electricity flow, or which way does current flow? Let me rephrase the question. Well, depends on how you orient it, but yeah, it go from positive to negative, right? So from positive to ground. That's the way current flows. But guess which way the electrons flow? The opposite direction. Okay, so why is it that we have that convention? Well, we can basically blame Ben Franklin for it. He had two choices, and he picked the opposite of what it actually is, right? So if you have a circuit and you sort of think in your mind that the current is going from plus 5 volts to ground, that's the way the current goes, but the electrons are actually going the other way, which drives me insane. So if anybody working on a time machine in their dorm room? Not this. Yeah, okay. You got plenty of classes to worry about. And really, you can transfer, bro. Okay. I mean, I know an alleged university just about 30 miles south of here that might take you. So, yeah. Uh, So yeah, if I had the time machine, in addition to dealing with baby Hitler and taking a sports almanac, uh, then I'd also make sure that Ben Franklin, right, that we got the positive negative thing right. Um, I'd also maybe like while I was at it with Ben Franklin, get him to switch the U.S. over to the metric system right when we were founded, and then we wouldn't have to deal with these irritating imperial units anymore. Wouldn't that be great? Yeah. So anyway, there's only two things that should be measured in imperial units as far as I'm concerned: football and beer. Right? You want a pint of beer. You don't want a half liter. You want a pint. And then football, well, that goes without saying. But American football, not soccer, because that's different. So anyway, um, and interestingly enough, actually, so I spent some time in Canada for a few months over a semester when I was on sabbatical, and I was working on a project where I needed some lumber, right? Just to, some wood two by fours basically to make like an enclosed area for a robot. So there's a Home Depot in town, so grab a van, off I go to Home Depot, and everything in Canada is metric, except when I got to Home Depot and I'm like, yeah, I need some lumber. I need it to be about, about 2 meters on either side, and this one needs to be slightly shorter and whatnot. And he's like, no, 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 no. We don't do lumber in metric. We do it in imperial. And it's like, oh, thank God, because it's like, okay, fine. Then I need two by fours, and I need this one, an inch and three quarters shorter because I'm going to make a square box. And he's like, oh yeah, okay, and out the door I went, right? Um, so uh, yeah. Anyway, okay. So the coordinate system, right? Now, the one thing about this image that's maybe a little bit misleading is this is it makes you think that the origin is in the middle. Okay, it's a little hard to see on the projector, but can you guys see just barely the grid line? That kind of makes you think that the origin's dead middle on the screen, but of course it's not. Okay. And so the reason that they put that there, though, is what they're trying to show is that the velocities are whichever directions. It's not trying to tell you where the origin is. Okay. But just remember, where is the origin? Top left. Okay. Okay. Good. Okay. So, and, uh, and it's also explaining what velocity is, but you guys aren't children, so you know what that means, right? What is velocity? Change in position. Uh, and we also can have acceleration, by the way, which what is acceleration? Change in, well, velocity, but yeah. Um, so actually, that's a good point. What's the difference between speed and velocity? Because we almost use the two words interchangeably in everyday life, right? Yeah, velocity has both a magnitude and a direction. Okay. So in our case, right, the velocity can be in any direction on the screen. So we would need to specify two coordinates to specify a velocity. Whereas the speed is a single number. And how do you go from velocity to speed? You do Pythagoras' theorem, basically. Okay. So let's say your velocity is 1 comma 2, then the speed would be the square root of 5 because that's the sum of the square root of the sum of the squares, right? Okay, so that's the difference. And yeah, right. Okay, sorry, get sidetracked. Okay, so we've got the things going, and let's make it look a little cool. Let's make it to make some effects. Okay, so what do we want to start projectile, start spray effect for 500 milliseconds. Okay, this is just basically to give it some particle effects. Okay, and obviously we can adjust this. There's some other things, so maybe this one is maybe that one's better. I don't know. What do you guys think? Maybe we could keep it on permanently. That looks pretty cool. Yeah, what do you think? Huh? Yeah. So it defaults, I think, to confetti, but you've certainly got some of these other ones that you can play with, right? So rings, this one might be appropriate in. Oh, that kind of looks lame. All right, well, I'll just do the trail. That's fine. Okay. Um, and notice that I said set projectile to start this effect as opposed to my sprite or something else. Okay. So this has it doing it from the actual projectile object and not the player. Um, and notice that if I fire multiple of them, right, it keeps it all sorted out. So that's kind of nice. Okay. Good. So that's just you know, that's art. Okay, looks cool. Any questions on that one? So a lot of this stuff, like eh, to maybe make a point that's obvious. Um, can you possibly break this? I mean, this is the nice thing about this web-based kind of programming. Are you going to break your computer if you just mess around and stuff? No. Okay, you can break a project. You have to try pretty hard to do it, but you're not going to break things. So for by all means, right, just start experimenting and see what happens. Okay. So how is it that, back in the day, right, when I was learning computing, uh, when I was first using a computer, we did not have internet access of any sort, like nobody did. This is something that only universities had and businesses and the government, right? So if I wanted to like do something, how did I learn how to do it? If there's no internet and no Google and no any of that. Did you guys ever hear about these things called books? Yeah, they're printed on dead trees and huh? Yes. We had to go down and check out stone tablets from the library that had the hieroglyphics on them. Okay. They were real heavy. Um, Yeah, and so you either had to learn stuff from a book or manual or something like that, or you just started experimenting with it, right? So if you knew some things and you'd be like, oh, what would happen if I changed this number to something else? And you'd see what would happen. And eventually you'd start to kind of figure things out. So please, feel free to experiment here. Okay, so let's keep going. Okay, so what's next? Let's get some enemies in here so that we have something to do. Okay, so we've still got all of our code from before. Okay. Um, and so what we need to do now is we need to have enemies appear on the screen periodically. Okay, how fast they appear, well, we could tweak that. One way that you can handle this is using this event called on game update. Okay, so that on game update purple thing will run whatever's inside of it every X units of time, where this number specifies how many units of time that it'll trigger it run everything, and then 500 milliseconds later do it again, and so on. Okay. Now, obviously, this number can be adjusted. You can type in, these are some common values. I'll just set it to 2 here for sake of demonstration, but obviously it could be whatever you want, sort of. Okay, it can't be too small, um, because let's say that I set this to 1 millisecond. Can I trigger this thing to run 1,000 times per second? That's essentially what that would be doing, right? Well, that's probably not going to work in the sense that the computer's not fast enough to really keep up with that much stuff at a time. So the fastest that you would probably ever really want to do something like this is every maybe tenth of a second at fastest. So you have to use this game update thing somewhat judiciously. If you abuse it, your game is going to slow down and get kind of jerky, and that's not fun. Okay, so yeah. Now, just to put this in perspective, what frame rates when you play games at are they mostly going? Right, like either on your Xboxes or play whatever's. What do you guys play games on? All right, who does console? Xbox, PS5. How'd you manage to find one of those? Did you have to bribe somebody? Did you have to program a bot? Okay, so I think something just happened with the power. Um, you hear that annoying buzz? That's from I think that's the fire alarm control panel that's in the basement. No, it's the control panel. Yes, exactly. Um, yeah. So, okay. It says we're still streaming, so I don't know what that was all about. So, okay, well, whatever. Let's carry on then. But the projectors just went out. Okay, let's see if we can get those back on. I think I'm going to have to turn them off and then turn them back on. Um, okay, what was I saying before that happened? Oh, right. Yeah, so the max frame rate, and on consoles it's usually capped at 60, right? And on a PC, you can, depending on the game and the hardware you're running it on, it can exceed 60. But there's not really much point in exceeding 60 unless you have a monitor that can refresh faster than 60 hertz. Most TVs um, are either at 60, or now the fancier newer ones are like 120 hertz refresh. Um, but so your PlayStations and stuff can drive that, but you've got to have the right hardware to do it. And on the Xbox side, I think this is the difference between what the Series S and X, right? The S is the slimmer one, and it does like 1080p, but the X is the more powerful and more expensive one that can do 4K. Um, okay, looks like we're back in business. Um, anyway, so a 60th of a second, right? Well, 100 milliseconds would be a tenth of a second. So a 60th of a second would be, 1/6 of 100, right? So like 16 milliseconds or so, roughly. Um, Anything faster than that, and like your monitor can't even display that fast, so there's no point in even trying to compute that fast. And make code, it will choke. It cannot do that kind of speed, right? I mean, you're running in a web browser, for crying out loud. So not on an Xbox. Okay. um, and at minimum, what do you want your frame rates to be sort of playable? If it's not minimum 30 frames a second, then you're having a bad day, right? Your stuff's too slow. Um, and I think most people nowadays think that 60 really is the minimum, because the frame rate shall be exactly 60. Okay. Right. So we'll make it every 2 seconds. And the way that, or a way that you can handle um, enemies is with, you can use projectiles here. Okay, so it's going to, in this example, they use projectiles both for the things that we're shooting and for the enemies. Okay, and we get a new block here, which is to say the place that the projectile gets spawned, okay, um, is from the side of the screen, okay, rather than being spawned at a specific sprite. Okay. All right. So let's get our enemy, and let's go into our assets, and we'll pick this one here. Okay. Whatever. And we'll call this, what did we say? We'll call it my enemy. Okay, so we're going to spawn it as a projectile, and then the next thing we're going to do is a little funny. Okay, we're going to, so if we spawn it from the side, well, okay, sorry, one thing. What velocities do we want to have? What do we want to have for our horizontal and vertical? Horizontal should be what? Yeah, 0, because we want the thing to move up and down. And vertical should be 25, but something positive. Okay, so let's just set it at 25 for right now. And why does it need to be positive? Because the enemies are going to be going down on the screen. Okay, we can adjust that number as needed. Okay, and okay, so we've got that. And then we need to put the thing someplace on the screen. Okay, so the sprites, so I'm going to do this. Okay, so I'm going to set my enemy to, I'm going to set its x coordinate to something. Okay, now what do I want its x coordinate to be when I spawn the thing? I want it to be some sort of random number. Okay, that makes sense. What should the range of those random numbers be? Well, what's the width of the screen? Yeah, it's somewhere between 0 and 160. Okay, and I might say do something like 4 to 155, just to take into account that I don't want the thing to kind of be off the screen a little bit. But point being, I want it to be somewhere in the horizontal range of the screen. Okay, so we'll just do, say, 4 to 155, I think I said. Okay, so how do I do that? Well, right here, you see I've got this number, right? If I set that to 0 or, well, any other number, every enemy would spawn at the same horizontal position. That's obviously not what I want. Okay, so under math, I'm going to pick a random number, and I can, you see how there's that little red thing and it's sort of connected by a yellow line? I can plop that into the socket, and now it will set it to whatever the value that's returned by this random function is. All right, and what did I say I wanted this to be? 4 to 155, or not, yeah, 155. Um, we can obviously tweak those numbers if it doesn't look good, but that gets at least the start. Okay, Gucci? Okay. All right, so let's see how it works. Looks pretty reasonable. Yeah, okay. Maybe the velocity is a little slow, but we'll just leave it for now. That's fine. Okay. So now what should happen? Okay, so we just did this, the randomizing. Okay. Um, so the last thing we're going to do is, so this is sort of one of the interesting things about this, this sort of object-oriented, it's not perfectly object-oriented, but it kind of is. So all the different sprites, okay, have types, right? Projectile is a type, enemy is a type, whatever. But things can actually change from one type to another. Okay, so right now we've created this thing as a projectile and we've called it my enemy, okay, whatever. But I can actually change its type to something else. And so what I'm going to do here, what do you guys think? Why don't we change it to being of the enemy kind? Okay, makes sense? Um, now, why might you want to actually be able to do this in a game? And be able to change the type that objects are as the game plays. Yeah. Yeah, and yeah, so if you wanted to be able to do enemy or damage to enemies but not players, okay. but maybe in certain instances, another player turns into an enemy. So like think, oh, I don't know, like a Final Fantasy game or something, or if you guys played any of those sort of RPG style things where you walk up to a guy and you're like, you start talking, and then depending on what decisions you make in a dialogue tree, then you either go into a battle or don't. Um, yeah. Um, so, uh, so it makes sense that being able to switch the types on the fly is something we want to do. Okay. Now, the reason that we need to do this here, um, to set the enemies to be of type enemy. I mean, there's nothing fancy about the name enemy. We could make that. I mean, that name could be chicken for all we care. It really doesn't matter what the name is. It just matters that chicken is different than beef or whatever, right? That they're different words. Okay. Um, so the reason that we need to do that is because in a moment, what we want to program is what happens if our player runs into one of these enemies. Okay. So what could theoretically happen, or what do we want to have happen if you run into an enemy? Yeah, you lose a life or you lose a health point or something happens. Okay. The other thing that we want to have happen probably is that the enemy ship blows up. Okay. And while we're at it, it would be kind of nice if when we shoot an enemy, it also blows up. Okay. So those are the things that we kind of want to do next. Okay. So we've set it to be of type enemy. Um, and now we're going to do the overlap stuff. Okay. So I'm going to do an event on sprite of kind player overlaps other sprite of kind enemy. Okay. So, this may be a little bit hard to see on the projector, but do you see how Sprite and other Sprite are in kind of a darker red than this color right there? It's kind of subtle. Yes? Okay. So the difference, and I wish they'd make the colors maybe a little bit more distinct from each other. Um, Sprite here is a placeholder. Okay. There is no object called Sprite. Okay, so what's going to happen is, let's say that sprite number one overlaps with sprite number two, and sprite number one is a player and sprite number two is an enemy. Okay, then sprite here gets replaced with sprite one, and other sprite gets replaced with sprite two. Okay, so then let's say later, sprite number 7 and 8 overlap. Well, then the placeholders are going to get replaced with those numbers. Okay, and you'll see why that's important here in a second. Um, okay, so um, okay, so I'm going to change the player life by -1. Okay, whatever, and I'm going to destroy the other sprite. Okay, so I'm just going to plop that in there. Okay, and then let's add some cool effects here so that it looks like it blows up. Kind of funny. Okay, so you see how when I overlap it, right, and I lose a life or lose a health point. Okay, makes sense? All right, so what's the problem now? Yeah, we haven't programmed any logic for how to deal with when our projectile overlaps with the object. Okay, but we have programmed what to have happen. Okay, so how did I get other sprite here? I just dragged this placeholder, and that makes a copy of the placeholder thing and plopped it in place to say which object do I want to destroy, and if I want to have an effect that goes with it, then I can do that. You don't have to. That's just making it look cool. Okay, so questions there? Okay, so what do we need to do basically in order to have our projectile, the thing that we're shooting, actually do something. Yeah, we need to have another one of these overlap events, right? Basically to check, has one of our projectiles overlapped with an enemy? Okay. All right, so that's what we need to do next. Okay, and so I'll do that. Okay, and now this time, what kind of overlap do we want to detect? Player with player or something else? Enemy with projectile. Okay, so you can have as many of these on overlap events as you want, basically for every combination of overlaps that you want to detect. Okay. Okay, so what do we want to have happen when an enemy overlaps a projectile? Yeah, we want to destroy, let's destroy the enemy with, and let's put some cool effect on it, like fire, I don't know. What else do we want to do? Yeah, probably want to destroy the projectile. Okay, because when a bullet hits something, it doesn't usually keep going. Necessarily. I mean, you could do like a laser beam or something that could like go through an object. Okay. All right, so let's test it out and see how it looks. Looks good, roughly. Yeah, what do you guys think? Yeah? Okay, so let's continue. Any questions so far? So is this placeholder business make sense? Because that's something that we're going to use quite a bit as we continue. All right, so we did that. And, oh, score. Forgot about that. When we destroy something, let's increase our score. Seems pretty good, right? And now, so when you first start the game, you have a health and that defaults to 3, and you have a score and that defaults to 0. Um, and the way it's pre-programmed is it only actually displays these things uh, once it changes by default. Now you can change that, obviously. Oh, oh, so why did that happen, by the way? So I shot, and you see how one of the bullets kept going? Yeah, because remember when I programmed this, I made 2 bullets come out in a slight like V pattern. So one of them kept going, the other one got destroyed, and the other one, the first one kept going, which, that's kind of cool. Okay. Um, and it'll keep track of your high score. That's sort of tied into a game. It's kind of fun. So you can, have high score stuff. Okay. All right, so that's good. Questions on this one? Not too bad, hopefully. Okay, so let's continue. And I think this one. Okay, so basically, what I want you guys to do, and I'll kind of cut the stream here and let you get to it, is really just continue with this series of um, tutorials. Okay, and until you sort of hit the end of it. Okay, now the what I'd also like you to do, and I'll post the Canvas assignment for this, is so I want you to finish these, okay, before Thursday, but then I also want you to add something to it. Okay, so this is where the experimenting and letting your creative juices start flowing comes in. okay, where you know, it takes you to a certain point, but there's a billion things that you could add. Come up with a thing to add and then do it. Okay. And what we're going to start with first thing on Thursday is, okay, what did you decide to add and how did you implement that? Okay. Or did you say, I want to do blah, and then you started trying to implement it, but it didn't work, or you couldn't figure it out or something, right? So that's kind of what I want to talk about on Tuesday, or I mean on Thursday, or to start anyway, is what did you think of to add and how did you approach trying to do it? Okay, does that make sense? Okay, so and when I say add something, add something simple, right? Like a boss or two different types of enemies that are sort of randomized or something like that. Not, you know, I'm going to add 16 levels and five bosses and, you know, lots of crazy stuff like that. Okay, we'll get there obviously, but don't try and do too much at once. If there's anything that I want you guys to learn from this class, I mean, other than the fundamentals of you know, programming, is I don't know how many of you guys played Cyberpunk at launch or have heard about what happened with Cyberpunk at launch. Okay, if there's anything that you're going to learn from this class, it's why games cost millions of dollars to develop and teams of hundreds of people and still come out really buggy, and you need like lots of patches for them to be playable. Okay, game design is an incredibly labor intensive process. So yeah. Um, okay, so I'll quit the stream here, and let's just kind of spend the rest of the time just kind of keep at it, and I'll kind of come around. Okay, good. All right.